My name is Muhammad Nur Ikram bin Juraidi. I'm third year civil engineering student at University Malaya. I'm currently performing my internship as a site engineer trainee at Geohan Sedang Berhad.
The project that I'm involved in is G685, the SU at Ampah Hileh. This project used the ball pie method for constructing the pies, and the soil layer for this project consisted of sand and limestone. In this video, I will explain pie driving analysis (PDA) by using a dynamic load test (DLT). What is pie driving analysis? Pie driving analysis was developed initially for driven pies and now universally accepted for cast-in-place pies. Dynamic load testing predicts the static soil resistance and the load or settlement behavior of the cast-in-place pies. By applying a high-energy impact load on the pie top, measure the force and velocity signals, and calculate the integrity and the ultimate axial compressive bearing capacity of the tested pie with the wave theory. What is the applicable standard for this test? Standard test method for high-strain dynamic testing for deep foundation is ASTM D4945. Let's move to the procedure for this test. Before we go to set up the equipment, we dive into how to construct a pie head for the tested pie. The first method is for existing pies. First, we need to excavate the soil surrounding the pie to give space for the worker to do their job. Second, we need to hack the pie until a smooth surface occurs. Third, we need to add steel reinforcement. Fourth, we need to install casing. The length of the casing is the same as the diameter of the pies. Fifth, the concrete needs to be done until the top of the casing. Now, all work has been done and the pie head is cast. The second method is to construct a pie head when the pie is ongoing to be cast. First, concrete the pie. Second, take out the temporary casing. Third, install 1 diameter pie casing length. Fourth, concrete until the top of the casing. And the pie head construction process is done. This is examples on-site process for the ongoing cast pie. Note that this method can only be performed by an experienced person, as soil contamination may occur due to soil collapse during the installation of the short casing. Now, we can proceed to the procedure to set up the equipment. Step 1. Excavate the soil surrounding. The depth is equal to 1 diameter pie. If the diameter pie is 600 mm, the depth excavated is 600 mm also. Step 2. Place the sand on top of the pie head that react as cushion for the pie. Step 3. Place the base on the pie head. Make sure that the pie is at the center of the base. Step 4. Weld the base with a steel bar to make sure that the base is not moving. Step 5. Place the plywood on the base to react as cushion for weight drop. Step 6. Place the weights one by one. The weight of each one is 10 tons. The total weight is 30 tons because the diameter pie is small. Step 7. Place the guard frame to guard the drop weight under the fall. Step 8. The sensor needs to be symmetrically installed on the pie side surface, not less than 2D from the top of the pie. The connection line of accelerometer hose and strain transducer hose on both sides of the pie should pass through the center of the pie. Step 9. Connect the transducer to the pie driving analyzer using cable. Step 10. Pull the weight up until it reaches the required height that has been calculated using Hiley's formula. From Hiley's formula, R stands for test load, W for weight of hammer, H for required drop height, eta for temporary compression, S for permanent displacement, and delta for hammer efficiency. Step 11. Drop the weight and the test is done. This is an example of when the weight is dropped on the side. Next, how we interpret the results. This is a summary case by with analyzed program, CAPWEB analysis. This summary shows the mobilized capacity value, skin friction value, and berry value, and settlement at 100% and 200% working load. What are the advantages and disadvantages of this test? The first advantage is the test is fast and inexpensive. Next, the test is suitable for both driven and cast in situ pies. Lastly, the correlation with a static test is good. The disadvantage of this test is may require calibration with a static test, and the results may be unrepresentative in soils that exhibit a realization. Lastly, the test cannot be done on a slope. That's all from me. Thank you for listening.